In the last video, we left off with a simple regular expression that matched any string that contained the character combination of %s. This expression used special meta characters in combination with each other. A regular expression can be made up of combinations of the following: literals. These have no additional meaning and are a one-to-one match. If you specify the literal ABC, the code will match on the first occurrence of ABC in your string. Character classes. Some of these are predefined, others you can define yourself. The period is an example of a predefined character class. Quantifiers. These meta characters identify the number of occurrences of a character class or literal required to make a match. In the example from the last video, I used the asterisk, but there are several others I'll review shortly. Boundary matches, or anchors. These specify the position in the text. For example, at the start of the text or the end. Groups. These identify and allow for the capturing of sub-expressions. More on this later. The table on this slide displays some common meta characters that fall into these categories. I'll be covering each of these examples shortly. You can find these examples and more by looking at Java's Pattern Class API. I will go to that site now and have a look at what's available. I won't go into any detail here, but rather I'll just scroll down the page through the categories. Characters, character classes, predefined character classes, and this list goes on for quite a while. You'll want to consult this documentation if you're trying to put together a new regular expression. All languages have slight variations as well, so you might need to make minor changes to a regular expression you found to work with Java. Getting back to the code now, let's start looking at each of these categories. I'll start by initializing a test string. This sentence will give me a variety of things to test for using regular expression patterns. I'll set up a replacement string which I'll use to replace each matched expression. I'll define an array of patterns to match, so first ABC, then 1, 2, 3, and finally just the letter A. I'll iterate over each pattern in the patterns array. For each pattern, I use the replace first method to replace the first occurrence of the pattern with the replacement string, the dash in parentheses. I'll then print the pattern and the resulting output. Running this code, it's pretty clear what was matched to the pattern. The first pattern ABC exactly matches the sequence of characters ABC in the input string. It's replaced with the replacement string. The second pattern 1, 2, 3 exactly matches the sequence of characters 1, 2, 3 in the input string and gets replaced. Character literals are case sensitive. The third pattern, just the letter A in quotes, matches that first letter A in the word anyone in the input string and replaces it. Character literals are hopefully pretty self-explanatory, matching exactly the characters specified and matching on the same case for this method. I'll change each of these patterns, add square brackets to the beginning and end of all three. Running this code. Notice the output for all three matches has changed. It didn't replace ABC in the first output, instead changing the letter C only. On the second line of output, it only changed the number 1, not the 2 and 3. Square brackets in a regular expression define a special kind of character class. Instead of all the characters in the same sequence making a match, this pattern means that an occurrence of just one of the characters within the brackets makes a match. Because I'm not including a quantifier, the first pattern, ABC in square brackets, means the code will match on the letter A alone or the B or the letter C, whichever is first. In this case, the letter C in the word can was the first character that matched, and C was replaced with the dash in parentheses. Again, with the second pattern, 1, 2, 3, the matching code will look for either a 1 or a 2 or a 3. The first matching digit will get replaced. As you see in the output, only the number 1 was replaced here. You can think of the square brackets as using an implied OR operator between the characters or digits specified. In the last case, putting only a single A in the brackets replaced the capital A at the start of the match. Characters in square brackets may have a different meaning. As an example, a period in square brackets will represent a literal period and not a meta character to match any character. You can actually use a meta character that means OR, which is a single pipe character, so I'll do that next. I'll remove the brackets and then insert that pipe character between the letter A and B, and also between the B and C. This really is the same expression I had previously, and I get the same result, I can use a combination of classes as well. In the next case, I'll match on either an AB or BC. So I'll change that expression, removing the first pipe and then including the letter B after the next pipe before the letter C. Running this code, the pattern will check for either the combination of AB or BC. You can see that the AB in the ABCs was replaced in this case. Okay, so next let's look at some predefined character classes. I'll update the first pattern to be the letter A, followed by -Z in square brackets, which is a pattern that will match any lower alphabetical letter. I'll change the next pattern to be 0-9 in square brackets. This pattern will match any single digit. Finally, I'll change the pattern to be capital letter A capital Z, which matches any single capital letter. If I run this code. For the first pattern, the first lowercase letter, regardless of what it is replaced. You can see that the letter N in the word anyone was replaced. For the second pattern, one was replaced, since it was the first digit. The last pattern did the same thing as the other two previous patterns, replacing just the capital letter A. I can combine these classes, and I'll do that next so that the first pattern will replace the first letter regardless of case. Running this. You can now see that the capital A was removed in the string instead of the lowercase letter n. This character class is one way to match any alphabetical character for the English language, regardless of case. I'm going to next add some quantifiers to these patterns, but first let me show the options we can use. There are 6 different quantifiers you can use in your regular expressions. The asterisk quantifier matches 0 or more occurrences of the preceding element. For example, B asterisk matches 0 or more occurrences of the letter B, such that an empty string, a single B, 2 Bs or 3 and so on, will all match. The plus quantifier matches 1 or more occurrences of the preceding element. For example, B plus matches 1 or more occurrences of the letter B, so these are the same matches as the B asterisk, but it won't match on none. There must be at least one B to match. The question mark quantifier matches 0 or 1 occurrence of the preceding element. For example, the pattern shown in this table matches both colour and colour that contains the letter U. The letter U is optional, so this quantifier allows for flexibility in matching variations in spelling. The curly braces quantifier allows you to specify an exact number of occurrences of the preceding element or a range. For example, B with 3 in curly braces matches exactly 3 occurrences of the letter B. If I include a comma after the number specified, B with 2 in curly braces, followed by a comma, this means there must be at least 2 Bs in any text for it to be a match. If you include 2 numbers in the curly braces, you're really specifying a lower and upper range. In the example here, I specify B, then 3, 4 in curly braces. Any text that contains a minimum of 3 Bs or a maximum of 4 contiguous B letters will match this pattern. Okay, so now I'll try out some of these quantifiers in my code. I'm going to add an asterisk to each of the 3 patterns. Running this code, you can see that in the first output the entire word anyone was replaced. So this pattern matched on all characters until the space. The second case may surprise you. It didn't replace 1, 2, 3 as you might have expected. Instead, it appears to have simply added the dash in parentheses to the start of the string. This is probably not what you wanted or expected. Remember that the asterisk matches 0 to many of the characters that you specify. In this case, it matched 0 characters, but still did the replacement. Lastly, I get the same result I've gotten for 3 other patterns, all of which simply removed the first A in anyone. I'm going to change that second pattern and now use the plus quantifier. Running that code, you can see this update pattern matched the 1, 2, 3 in the string and replace that. The plus sign matches 1 to many occurrences. I'll change that pattern again. This time I want to match on an exact number of digits. Running this code, you can see it matched on the first 2 digits of 1, 2, 3, replacing the 1, 2. Okay, so that's a brief introduction to some character classes and quantifiers. Now let's look at boundary matches. There are 3 common boundary matches or anchors. These are the caret, which will match to the beginning of a string of text. The $sign matches to the end of the text. And \B is a word boundary. Whenever the meta character has a backslash, you'll need to escape the backslash with a second backslash in the Java string literal you use for the pattern. I'll show you this shortly. In the example shown here, any of the words are removed if they start and end at a word boundary. Okay, so let's look at these in code. I'll go back to my patterns. First, I'm going to add a $sign at the end of the first pattern. The $sign is the boundary matcher, or anchor, meaning match at the end of the string. In this case, the pattern preceding this character will be applied, starting with that anchor point. In the second case, I'm going to completely replace that line. Instead, I'll start with the caret symbol, which says I want this pattern to apply to the start of the string. I'll add square brackets and use the A to Z, capital A to Z character class here. In this case, though, I'll follow it with a quantifier that says I only want to match exactly 3 characters. Finally, I'll again replace the third pattern. I'll use a combination of characters, so a custom character class first, in square brackets containing both a lowercase and uppercase letter A. That gets followed by the letters NY. I'll end with 2 backslashes and the letter B, which is the meta character for a word boundary matcher. I'll run this code so you can see the output. Notice what got replaced in the first output is not the first word anymore, it's the last word. So expression was replaced with the dash in parentheses. This is because the $sign in the pattern said to start searching at the end of the string. In the second case, matching characters must be at the beginning of the string because I'm specifying a caret character. I also said I wanted to match exactly 3 alphabetical characters, so the any and anyone was replaced in this case. But look at the last one. It's the second occurrence of any that got replaced and not the character sequence in the word anyone. Because I used the word boundary \b, the characters ANY had to end at a word boundary, which the ANY in anyone didn't. Okay, so I hope you're getting a little more comfortable with regular expressions. I'll end this video here before it gets too long. In the next video, I'll pick this code up and start reviewing other methods that use irregular expressions with additional character classes. See you in the next video.